So this tends to be a pretty verbose section, so a lot of writing. I'll try and kind of highlight the things that I think are important to take down into your notes, but always remember I record these lectures so that you can revisit them if you need to go back, and you also have access to the slides themselves in the module, so don't feel like you need to frantically write every small piece of information down. All right, let's talk about statistics and statistics. So statistics, capital S, describes the science of basically data analyzing, right? So it's the science of collecting data, organizing data, and interpreting data. So this is like the mathematical side of statistics. This is where our theories come in that allow us to draw conclusions from a data set. It's a pretty young science. The reason is we only recently, in the late 20th century, started being like sort of a computer-based society and started collecting large amounts of information, large amounts of data, and that sort of necessitated us being able to analyze that data in a meaningful way. We're not computers, we're humans. So if I just vomit a bunch of numbers at you, it's very difficult for you to just stare at numbers and analyze them meaningfully and understand what's going on with that data set. So we did things like we figured out some theoretical ways to condense those numbers into a single number that sort of helps us represent the whole, and also to graph the data that gives us a better visual perception about what's going on with the data, right? Because, like I said, we're not computers. We can't just look at a matrix of numbers and be like, got it, I understand this. I can see all the patterns. All right, and then statistics, this should really be a lowercase s. Statistics are the data that describe or summarize something. So really, and this isn't as accurate a description as I like, a statistic is a calculation made from a sample. And so that would be like, all right, what if I'm interested in the average height of all students taking QR? Well, you guys are at home. I'm not allowed in Kenton's room. He has a, what's that called? I'm not allowed to come within 100 feet of him anymore. Yeah, he has a restraining order against me. I'm just kidding. And so what I could do then is go, oh, I have a sample of whatever, 7 people in here. I'm going to take their height and I'm going to calculate the average, and I'm going to use that as my best guess for the average height of all students who take quantitative reasoning. That value, that average value of your height, since it comes from a sample, that is a statistic, okay? Now, and we're going to get to this, but just to give you a heads up, that differs from a parameter, which is a true value about a population. So we basically use statistics to estimate parameters. Does that make sense? So easy alliteration. Statistic comes from a sample. Parameter comes from a population. But a lot of times we can't actually calculate the parameter because the population's too large, or your colleague has a restraining order against you, or whatever it is, right? And so the best thing we can do is take a sample, make the calculation on that sample, and use that statistic to be our best guess about the parameter. Does that make sense? All right. Aiden says legally people above 6 foot aren't allowed to be in the same room because it's a fire code violation. So that's why me and Ken can't be around each other. All right, and this is what I just described to you. So the population is the set of people or things being studied. Okay, a population depends on the context of what you want to study. In my little example, the population was all students taking QR. A sample is a subset of the population that we actually make calculations on. So if I'm trying to figure out the average income of all working people in the US, does that number actually exist? Is that a number that exists? Meaning, if I could freeze time and I were omniscient, so I could just know everybody's income, could I calculate the average income? Not a trick question. It's a number that's out there, right? That number exists. But my point is that number, can you actually calculate that number? Could you physically calculate that number? I mean, if I gave you an assignment and I said, Naomi, your only assignment this year is to figure out the actual average income of all working people in the United States, the true average. And if you do it, you get an A, and if you don't do it, you get an F. Is it possible that you could get me that number? You think it's possible?
No, maybe not, but no. I don't know.
It's probably impossible. First of all, that's a huge population. Second of all, it's constantly changing. People are constantly losing their jobs, gaining jobs, getting raises, getting pay cuts. There's millions and millions of people working. Unless you could literally freeze time, right? At one point in time and take 100 years to go around and interview every person and assuming they're truthful, it's not a possible number to calculate for those reasons, right? Meaning practically it's not a possible number. That number exists, but it's pretty much impossible to truly figure out. So the best thing we could do is get a sample to work with, right? And use that sample to make the calculation on and use that estimate. So my point is, lots of populations are either too large to practically make computations on, or they're dynamic, meaning they're constantly changing as time goes on. And so parameters are the numbers that are true values within the population. Those are the numbers we'd like to know. That's the true average income of all working people in the US that I'm sending Naomi out on a Sisyphusian task to try and complete. But since we often can't calculate the true parameter, instead we use a sample statistic. So we round up a sample, we make our computation based on that sample, and we use that as our best estimate of the population parameter. So a statistic estimates a parameter. Go ahead. Is the parameter that I described in which one? Yeah, it's the same as the population parameter, yes. So when you say parameter, it's understood to mean population parameter. When you say statistic, it's understood to mean sample statistic. All right. Good. Basic diagram that shows what I'm talking about. You have a population, you go in there and you grab a sample, some subset of the population, right? And the way statistics, oh, actually, I guess I thought the diagram was next, but let's do an example. So in this example, I want to describe the population, the sample, the parameter, and the statistics. So the population is the group of individuals we're interested in studying. The sample is the actual subset we went out and studied. The parameter is the calculation we want to know about the population, and the statistic is the actual calculation we made on the sample, right? Now, you're often going to be able to infer the population based on the sample that they took. So I'll go population sample, and then we'll do parameter. Statistic. All right, so agricultural inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the county. I would start with the sample because I think that's the easiest one to identify. And once you know the sample, from that we can deduce what the population of interest that they're trying to study is. So anybody in the chat or in person, what's the physical sample they took? $25 what? That's it. The sample they actually looked at was 25 ears of corn. So they actually studied 25 ears of corn because they were interested in what actual population. Go ahead, Naomi. So we're getting there. They're interested in corn in general, right? At those corn producing farms. For the entire world? Okay, so what we're going to say is the population is corn produced in Jefferson County, right? Whoops. So whatever the units of your sample are, your population is going to have the same units. So if we're talking about corn in our sample, the population is going to be corn. And then you just have to narrow down how much corn are they interested in. Every ear of corn in the world? No, probably not, right? They're not studying pesticides on corn in Jefferson County to draw conclusions about corn being grown in China. They're just interested in the corn in Jefferson County, the corn being produced there. Does that make sense? All right. The statistic, all right, the calculation that they're actually making, what's the thing they're actually measuring? Yeah, the levels of residue specifically, right? All right, so my statistic is the levels of residue specifically on 25 ears of corn, right? So that's on the corn that we actually went out and sampled. And my parameter, the thing that I'm actually interested in estimating, is the same thing, the levels of residue, but on what? Go ahead, Grace. Yeah, on all the corn in Jefferson County, right? So the levels of residue on all corn produced in Jefferson County. Good. Yeah, thanks, Colin.
So I have a question.
Go ahead.
So a parameter is what we're trying to find,
Yep.
and then the statistic is basically the best guess based on data.
You got it.
Okay.
So this is a good example why we need statistics, because they couldn't, like, farms produce corn to turn a profit, right? And they couldn't truly go calculate the level of pesticide on every ear of corn, because the way you would have to do that is you have to actually harvest the corn to measure the pesticide. So if they go out and harvest all the corn, then they don't have any more corn to sell. So another reason you need statistics is because sometimes you're trying to measure for quality assurance. And to do that, oftentimes you have to actually terminate the individual that you're sampling. So think of a battery factory, right? And they want to make sure that they're producing batteries that last a certain amount of time that they're advertising. Well, the only way to test a battery is to kill it, right? You actually have to use it until it's dead. So they couldn't test the whole population or they'd kill all their batteries. So what they'll often do in a factory, and we'll talk about this a little more, is they'll like take every whatever 12th battery off the line and test that battery. All right. Let's talk about basic steps in statistical studies. And I'll give you a diagram that kind of represents this, I believe, after this. So first, you're going to state the goal of your study precisely. Then you go out there and you choose a representative sample from your population. This is one of the most difficult steps in a statistical study. It costs a lot of money and it takes a lot of time. So this is really obvious in like election years, because in election years they do a lot of polling, and so you'll often see like in this poll, 52% stated they'd vote for candidate A or whatever. But especially when you see them done by news organizations, the polls are generally untrustworthy because they're doing the polls based on their viewers, because news organizations are largely partisan now, right? Somebody who watches CNN largely votes differently than somebody who watches Fox News. Their polls are often completely biased, and we'll talk about, I'm sure you have an intuition for what bias means, which makes them untrustworthy. So you want like an independent polling organization, like Pew is one, or Gallup. Those are two famous ones. But to get a real representative sample, you have to go out into the public. And because, especially in terms of politics, people tend to even separate themselves by almost cities or landmarks, right? So you have to go to multiple cities. You couldn't just, for example, you couldn't take a poll outside of Jobot and expect to get a reasonable representative poll for a political poll, right? Like people who go to Jobot are probably largely liberal in their, or progressive in their views. This is like downtown is a progressive part of town. So it takes a lot of time and costs a lot of money to get a truly representative sample, because you have to go get them people from all over. All right, once you have your sample though, then you're gonna make your calculations, right? You're gonna take the raw data, which means if it's who are you gonna vote for, that's your raw data. And then you're gonna make your computation. So you might go, okay, blank percent, 52% of my sample said they'd vote for candidate A. There's your statistic. And then you use that statistic to infer, and infer just means draw conclusions about your parameter. So you're just going to use that as your best guess, your estimate of what the overall population parameter is. So in my case, I go out, I can survey a bunch of people about who they're going to vote for. I calculate, 51% of my sample said they're voting for candidate A, so my best guess is that 51% of the population will vote for candidate A. How good a job your statistic does at estimating your population is largely dependent on step 2, how representative your sample is. Like I said, that can be very difficult, and in real life, that's the most time-consuming and thus costly part of a statistical study. And then you draw conclusions. All right, so it kind of looks like this in a diagram. So you start with a population. You draw a sample. You calculate statistics. You make inference about the parameter. And then you draw conclusions about the population. Pretty straightforward, right? So we saw this. And we'll talk about, there's different kinds of statistical studies. There's experiments and there's observational studies. But we just had a huge global statistical study. The vaccines, right? Huge global statistical studies. Probably the largest statistical study done easily in your lifetime. Probably in my lifetime as well. Where they took the world's population. They took a sample. In this case, this was probably the easiest time there was ever to take a sample because, you know, people were falling over trying to volunteer to be in the vaccine study. But they did an experiment, which means they had to test the vaccine against what's called a control group so that they could weed out this thing called, do you guys know what the placebo effect is? We'll talk about it. But especially in medicine, the placebo effect is prominent because your body works in a way where you can have psychosomatic effects just based on what you think should be happening, and your body will react to that, right? So a lot of times you can be like, I'm getting better. Like my wife takes like echinacea when she gets a cold. Echinacea doesn't do anything. It's just like an herb or whatever. And she's convinced it works. So sometimes it does work because if you feel like you're getting better, sometimes your body will help you get better. But they want to test the vaccine against the placebo to see, is this better than just the psychosomatic effects of you thinking you're getting better? So a lot of people in that study just got an injection of saline, just nothing. And they were told that they got the vaccine. And then half the people did get the vaccine. And then they compare, how did the people who got the true vaccine fare against the people who just got the placebo? And if this one's better than just these people who thought they got better, then the vaccine truly works, right? And so we found out that it does work. It works much better than the placebo. All right, that's another diagram showing you the exact same thing. I don't know why I thought I had to put it in so many times. Okay. Example 2. Each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the unemployment rate, defined as the percentage of people who are unemployed among all of those who are either employed or actively seeking employment. Describe how the 5 basic steps of a statistical study apply to this research. All right, so we start with the population. And our population of interest is all U.S. households. Now, it would be impossible to survey every single U.S. household every month, right? So they employ statistical techniques to try and make estimates about how the workforce is faring by taking a sample of a large amount of US households. So we're going to like this. We're going to go from there. We sample 60,000 households. Okay, so that's our sample. Once we take our sample, we're going to calculate, and let's just focus on the statistic that they're talking about, the percent unemployed. There's our statistic. And from there, infer that this is roughly, and I say roughly, hold on, roughly the unemployment rate for the US that month. And I say roughly because if they sampled a different 60,000 households, do you think they would get the exact same percentage of unemployed people? No, right? Likely not. And that's not because they didn't take a good sample. Even if you take a good sample that's representative, you're going to get slight differences from sample to sample, right? That's called sampling variability. So when we make this inference, we know that there's probably a little bit of a buffer, a little bit of a margin of error, but we're drawing conclusions that this is roughly what the US unemployment numbers are for this month. And from there, our fifth step is just going to be draw conclusions about the US economy. Or about the US population in general. Right, so those are our 5 steps. We start with the population, we take a sample, we calculate our statistic, we use that to make inference about our population and draw conclusions. All right, sorry, that's pretty small. All right, I think we've talked about this enough that hopefully this is intuitive. But a representative sample is just a sample in which relevant characteristics of the sample members are generally the same as those of the population, right? So it just means that it doesn't lean hard one way or the other, and it's representative of the whole. And I guess the easiest way to think about it is like an unrepresentative sample would. Do we talk about bias in here? I hope so. It would contain bias, meaning it would lean one way or the other. Like if you went to JoBot and decided to survey people about their political views, probably not a representative sample about the greater Arizona view of politics. I don't know. I feel like I'm not meaning to malign JoBot. I love JoBot. I just think that it's like a space for college students and like the progressive people who work downtown. All right, let's talk about some different sampling methods. So the most basic one is called a simple random sample, and you can abbreviate that as SRS. And that's just when you choose a sample in such a way that every sample of the same size has an equal chance of being selected. So this is your most basic way of sampling. But it's often, it's usually it can be very representative, which is good. That's what you want, but it can also be very difficult and expensive. So An example would be like, let's say I want a representative sample of students at the school. I want 50 students that represent the school as a whole. I don't know. What am I trying to study? Let's say height, because I'm boring and I can't think of anything else. So I want to know the average height of a student at the school. So one thing I can do, you guys all have ID numbers, right? Associated with your name. So I could tell my calculator to take a random sample of 50 ID numbers. And then I could go find the students that correspond with those ID numbers, right? But that's going to be really difficult and time consuming for me because I have to go find where each student is, go locate them in the school times 50, right? So while a simple random sample can be representative, it's often very difficult to actually use in real life. And it also, there's always the chance that it's not representative because if every sample has an equal chance of being selected, it could happen that I accidentally get a sample that has 49 seniors and 1 fifth grader, in which case I'm probably not going to get a good estimate of the average height at the school, right? Now that's not super likely to happen, but there's always the possibility. All right, and then there's systematic sampling. And this is where you use a simple system to choose the sample. And this was like what I was talking about at the battery factory. Generally, what you'll do is randomly select the first individual, and then you'll have a system for selecting after that first random one. Like you'll go, I'm going to randomly select the first battery, and I'm going to take every 10th battery off the line after that. So I'm going to say simple random sampling, mostly good. Meaning roughly representative most of the time. Although you always have the chance of getting a bad sample, but that's not super likely. Systematic sampling, mostly good, especially for when you're trying to sample for like quality assurance, right? Like a factory line, something like that. It would also work really great for if I'm trying to get a sample of 50 students. Like I said, what I could do is just wait till the end of the day, the bell, and I could randomly select the first student and then take like every 10th student after that comes out the door, right? And that would be much more efficient for me. And then there's convenient sampling, which is what it sounds like. Choose a sample that's convenient. So I could go, what's the average height at the school? I'm going to use you guys because you're in my classroom right now. This is bad. This generally does not give you a good sample. So I have to figure out how many people are going to vote for Trump. So I'm at Jobot having a coffee. I'll just ask these people. Probably not going to get me a representative result. Yeah. Yeah. Oh boy. CNN, Fox. I mean, when you're polling your constituents, right? Your viewership, that tends to be a convenience sample, and those tend to, I mean, all the time. Any what we call a voluntary response sample is basically a convenience sample. So in my actual statistics class, we talk about a bunch of these. Like there was this lady who was her name was Sheer Height, and she was like a respected relationship counselor that wrote like an op-ed for the New York Times or something. And then she was writing a book, and she did a survey of 100,000 people about if they had had an affair in their marriage, like 100,000 people, married people. but she had sent out the survey to the 100,000 people. So it was a voluntary response, and obviously everybody didn't send it back in. But she got like something like 5,000 return surveys. And of those 5,000, 75% of them said they had an affair, right? And so in her book, she published that statistics and inferred that 75% of marriages have infidelity in the relationship, like their partners, like 75%. Except what she didn't post is that she only got 5,000 out of 100,000 back. So that's a 95% non-response rate, which means like what kind of people are responding to that survey, do you think, right? Maybe people who are having trouble in their marriage. But if 95%, I mean, I know that if I got that letter in the mail, I would be like, I'm not responding to this. I don't care. And so, I mean, that's an example of convenience sampling. You're just sending a survey out to your readership. It happens so often. So those are some of the types of questions you need to be asking when you're reading some of these statistics. Is like 75% seems high. How was this survey conducted, right? Go ahead.
So for simple random sampling, what does size mean? Every sample of the same size?
It means, so if I'm trying to choose a sample of 50 students, all possible samples of size 50 are equally likely to occur. So what wouldn't be a simple random sample is if I go, I'm going to randomly select 50 students, but I need it to be 10 boys and 40 girls. Because now I've put a parameter on it where every possible it's not a possibility to get all 50 to be boys or all 50 to be girls, and that should be a possibility in a simple random sample. Does that make sense?
Yeah.
Okay.
So like
Any combination has to be equally likely to occur. Exactly. All right, and then there's a couple more. Yeah, so the last one that we're going to talk about is something called stratified sampling. And so we use this often when we're concerned about differences among subgroups, which we call strata. And so like one way they'll do this with political polling is that oftentimes there are significant differences in political ideologies based off race or ethnicity. And so when you're conducting a political poll, if Arizona, let's say, is, I don't know what the statistics are for our race breakdown in Arizona. I'm going to make them up. Oh boy, I have no idea. Let's say 60, I should have some idea probably. I've lived here my whole life. 60% white, 25, I don't know, these are made up numbers. 25% Latinx, what does that make? 85? Let's say 10% Black. Okay, 5% AA or Pacific Islander. That's 100, right? All right, let's say that were our racial breakdown in Arizona, and you wanted to conduct a poll concerning what percent of people are going to vote for candidate A. Well, if you take a simple random sample, you always run the risk of getting a sample of all white people, right? Or all of any other ethnicity. And if political ideology does significantly differ by race breakdown, you would want to make sure that each race is represented in your sample, right? So what you would instead do is go, okay, to make sure that this happens, I'm going to make sure that my sample is a random sample that's 60% white people, 25% Latinx people, 10% Black people, and 5% AAPI. Does that make sense? And you would figure out a way to go out into the community and sample that many of each race or ethnicity. And so what you've done then is broken it up into strata. You're going, I'm not just taking a simple random sample of people, I'm taking a simple random sample of a certain number of each ethnic group. And that way everybody's represented. So let's say you wanted a sample of size, usually we denote sample size with lowercase n. You wanted a sample of size n equals 100. You would take a simple random sample of 60 white people, a simple random sample of 25 Latinx people, a simple random sample of 10 black people, and then a simple random sample of 5 American, Asian, or Pacific Islander people, and then you combine those, and that makes up your sample of 100. And each strata, remember, you're still taking a random sample within the ethnic group, but then you're combining the whole thing to make your sample, and it's going to be more representative because it's inclusive of these different ethnic groups, if that makes sense. All right. Here's just some diagrams that kind of show a visual of what we've been talking about. So in a simple random sample, generally we'll use a random number generator to select it. So you have what's called a sampling frame, and that's like you associate the individuals in your population with the number. So for you guys, if I was sampling students at the school, you're already associated with the number, your ID number, right? And so that makes it real easy. I could just go into the computer and go, hey, take 50 random ID numbers, and then go out and select those students. Convenience sample, this is my favorite visual, especially the question. Hey, do you support the death penalty to a random person on the street? That's a convenience sample. Systematic, you take every Kth member. And then stratified, you partition the population into strata that you already believe differ on the subject that you're trying to study. So in this case, they're saying, okay, males and females differ on whatever they're trying to study. And then you go into those and you take a simple random sample from each strata and combine it to make your overall. All right. So now I'm going to give you some scenarios. You're going to tell me what sampling technique we're using. All right, this one's just a visual. Based on this visual, the first one is my population. What sampling technique do you guys think is being used there? Go ahead, Grace. Good. Stratified. We have the population. It looks visually like they believe it differs based on the color of these game of life characters. So they separate those first, and then they take a simple random sample from each strata to combine it for the overall sample. Naomi? You think it's simple random? Megan? Yeah, it could be, but just based on the visual, here's the pollster's being lazy, and just taking the ones near them. This is illustrating convenience. Naomi? There we go. This one looks a little bit more random, right? The pollster just seems to be selecting random people from the population. Oh, you can't really see. Sorry, let me scroll down. Takers, Zoom chat. Grace? Yeah. As you can see, it's 2, 5, 8, 11. So the first one is seemingly random, but then after that, it's every what? every third after that, right? So systematic. Good. I think I deleted something because I don't know. Oh, you know what? I know what this is. So here I'm going to give us the statistical study we're trying to produce or the sample we're trying to get, and then we're going to decide what we think is the most efficient sampling method here. So let's go back to our agricultural inspectors for Jefferson County, and they're trying to check the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms. What method makes the most sense for this? Yeah. So I get what you're thinking here. This is actually stratified, but you're right. The reason it's stratified, you are taking a simple random sample, but they already pre-stratified it for us because we want 25 ears from each separate farm. So the strata are our 104 farms, right? So we're going to go to each of the 104 farms and we're going to take a simple random sample. But since we're already predetermining that we're going to each farm separately, it's stratified, and those are the strata. Stratified, and I'll make a note. You're taking an SRS from each farm, and that's our strata. All right. Anthropologists determine the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. So what kind of sample are they using here? And I'm going to kind of push it on you a little harder. Notice that they're all just from southern Europe at 3 sites. Yeah, it is convenience, right? And it's convenience by necessity. Convenience, I said, is a bad sampling method, but sometimes that's all you have. If all they have are these, it's not like they can't just like go, okay, I'm going to choose random plots of land and hopefully I'll get a Neanderthal skull there or whatever. No, all they have are the Neanderthal skulls that they found. So that's the only thing they have to make inference from. It just happens to be a convenience sample. Oh, good, we do talk about bias. Okay, this is a definition you guys need. And we're not going to go all the way through this, I promise. I'm going to find a good stopping point because we've been going for a while. But let's do this. All right. All right, so a statistical study suffers from bias if its design or conduct tends to favor certain results. So bias is largely introduced due to the sampling technique, which we already talked about, or survey style. There's a million different types of bias. So we already talked about sampling technique. If you use a convenience sample, it's very easy to introduce bias. If I'm at JoeBot and I just ask the people around me what they think about gun control, probably going to get a pretty consistent answer. That's maybe not the same as the answer of the greater population of Arizona, right? So that's bias. But oftentimes, especially when we're polling, you're using a survey, right? And so there are tons of things that can introduce bias in a survey. There's response bias. So that would be like, okay, I'm trying to study the average caloric intake by meal of a McDonald's customer. And the way I did it was I stood at the door, and as they walked in, I go, hey, can I grab your receipt on the way out? I'm trying to see how many calories you're going to consume. Well, that's probably going to affect the way that they order, right? If I tell them I'm going to be studying their caloric intake, they may not supersize that meal when they wanted to prior to talking with me. You know what I mean? So that's something called a response bias. Or there's even more subtle things, like people get survey fatigue. So if you have a survey with multiple questions, 10 questions, let's say, and you constantly give them out in the same order, the response on the 10th question probably won't be as accurate as the response on the first, because people tend to give up on surveys, right? They're just like, all right, get this out of my face. So one thing you can do to account for that when you're giving a survey is make sure that you make multiple versions of the survey where the questions are in different orders to avoid survey fatigue, right? But there's really no way to conduct a statistical study and completely eliminate bias. You're just trying to reduce it as much as possible. All right, so I think we're going to stop there. Listen, we have a problem set that's associated with this that you can find in the module. So I would try and get maybe halfway through. I'll change the due date to be next Wednesday, because what we'll do is finish this up on Monday, and we're going to be talking about different study designs. So we're going to talk about observational studies versus observational studies versus experiments. I was reading your comment, Colin. He says, I saw a really interesting video on survivorship bias that used planes returning with bullet holes as an example. I think I've read about this. I need to know more, though. Yeah, there's tons of weird types of bias. Anyways, so try and get halfway through this problem set, and I'll give you some extra time. I'll change the due dates. You don't need to do the open note quiz yet, because we didn't get all the way through. So don't worry about that quite yet. I'm going to go in and change the due date, but do get started on these problems. Online, unless you have questions, feel free to log off and get started.